In Java, both static and instance members are used to define the behaviors and state of a class. They serve different purposes and have different characteristics. Instance variable belongs to a specific instance. Instance methods are invoked by instance of the class. Remember what instance variables are. Let's say we have a class named X. You can instantiate this X object reference by way of new X. This uses a default constructor, and X object will be the instance variable. And this instance variable belongs to a specific instance or a newly created object at runtime. Instance methods are the methods or member methods. Sometimes people call it member functions inside this X class that could be accessed by X object dot, whatever this function name is. So these are the instance methods. This is one example of it. This can only be invoked by an instance of the class, which is X object. In a class X, there are data fields. These are what we call instance data or instance member. There's also methods, and these are what we call instance methods or member functions. Static variables, on the other hand, are shared by all of the instances of the class. These variables are declared with the word static. When you have static in front of a method, that method is not tied to a specific object. One example is your main console. This main method is declared as a static void and public, such that this main method is not tied to any specific object, namely the whole class that encapsulates this main. You can also define constants that are static. These are final variables. Final means immutable or cannot be modified, meaning you cannot write into this variable. You can only read from it, read only. When a constant is defined as final static, that variable could be seen and shared by all of the instances of the class. This is useful for implementing, for example, factory methods, helper functions, or methods that perform operations on a class level data. Sometimes you'll see static, often used for utility methods or constants that are not dependent on the state of individual instances. So if you want to create global constant, you can use static final. Either fields or static could be declared with a static keyword in front of it, making them static variables, constants, or methods. When a static modifier is used, that means that particular field or variables, constants, or methods, there's only one copy of them in memory at runtime, and they are shared among all instances of the class. Let's look at some concrete examples. Let's say you have a circle class. This is an UML representation of the circle class. We use underlined to indicate static variables or methods. So circle has radius field as well as number of objects. This field number of objects is a static. So is the method section, where get area is an instance method. However, get number of object is a static method. When we instantiate the circle, meaning we can do circle C equals new circle, assuming we're using a default constructor, this creates an instance of a circle called C. For brevity, let's say this is circle 1, and we'll have the same thing for circle 2 equals new circle. Again, we're using default constructor. So you have circle 1 and circle 2 being the instances of the circle class. Circle 1 has a radius 1, circle 2 has a radius 2, but both share the same static number of objects. Remember, number of objects is a static field. Once assigned a value of 2, this field could be seen or accessed by both objects, circle 1 and circle 2. This is the beauty of static. Namely, once declared static, there exists only one copy of it in memory, shared among all instances of the class. If you change this number of objects to 3, let's say in circle 1, this number of objects will also be 3. If you change this to 100, this will be 100 as well. As you can see, when something is static, it is also quite dangerous. The fact that it is shared among all of the objects or instances means anybody can change them. This is the reason why sometimes we define a static constant as a final static. Final means read-only. You cannot update or modify it. Let's look at a code snippet that illustrates both instance and static methods and fields. Let's look at this piece of code. You have my class that encapsulates a whole bunch of stuff. There's a static data field, instance field. The difference being static field is declared with the keyword static. Instance field does not have static in it. You also have static methods. The difference between the two is the static method has the static keyword in front of it. The instance method does not have the word static. Now let's look at this entry point. This is a console application where main method is your entry point. It is also a static, which means you don't really have to instantiate my class and run it in order to run the main. This is the reason why main console application is a static. Now let's see how we access static member. Because there's only one copy of a static field, you can access it by way of using my class dot static field. Note the name of the class. This is not an instance, but the name class. To access both field and methods that way. You can also write information into it. However, for instances, you'll have to create objects from my class first. Then we can access these instance members, like your instance field and instance method that way. Note the difference between my class versus object. This is the instance way of accessing data. This is the static way of accessing data. Note that in any given class, you can have both static and instance declarations or methods coexist in the same class, but their retrieval and invocations are different, as illustrated. This concludes our quick introductions of static versus instance.